Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what is the difference between a list and a set? Let me answer this question with practical demonstration. So what is the difference between a list and a set? Both are the interfaces in collections framework, guys. List is one of the predefined interface in collections framework, and at same time set is another predefined interface under the collections framework. So what is the difference between these two interfaces? I'm going to explain one by one now. Okay. So first thing about the list is it allows indexing. Okay. It allows indexing. Elements can be accessed by using their index. The first element will be stored at the index 0, second element will be stored at the index 1, third element will be stored at the index 2, like that. That is what is indexing, guys. But in set, we don't have any indexing concept. Okay, elements cannot be accessed using index here. Okay, in set, we cannot access the elements using the index, whereas in list, we can access the elements using their index. And the other important thing that you have to understand about the difference between list and set is the major or popular implementation of this interface. Okay, there are multiple classes in collections framework, which are the child classes of this list interface. But ArrayList is a major one or popular one that most of the people use. Similarly, coming to the set, right, the popular implementation of this particular interface, the child class which is implementing the interface set is there are multiple classes which are implementing this set. Out of that, HashSet is a popular one. Okay, so when I'm taking examples for explaining all these differences, right, in case of list, I'll use the array list, and in case of set, I'll use the popular implementation of that interface HashSet. Okay, to explain all these differences. First, I'll cover the indexing and non-indexing, no indexing concept of the list and set. Further, I'll go with a practical demonstration, guys. I will switch to the Eclipse ID and create a new class here. I'll just go into create a new class. I'll just name this class as list versus set demo. Okay. With main method, I'm going to create, click on finish. Okay. So first, I'm going to create a list. Okay. But you already know in Java that you cannot create an object for the interfaces. So list and set are interfaces. Can you create object for the list or set interface? It's not possible. You will get error saying that cannot instantiate the list or set kind of stuff. Okay. So what we have to do is we have to create an object for its child class, like popular child class like array list, and that object of the child class we have to assign to the variable that is declared with the list interface. That will be possible. Okay. I cannot directly create an object for the list interface. You see, list is equal to new list. This is not possible, guys. This is not possible. Hold the mouse on this and import this list from Hold the mouse on this list and import this from java.util package. But still you will get an error here saying that this particular list cannot instantiate. Okay, cannot instantiate the type list. That means you cannot create an object for the interface. So though you cannot create an object for the list interface, you can create an object for its child class which is implementing this parent interface known as list, known as one of the popular child class which is actually implementing the parent interface list is array list. I can create an object for the array list. Hover the mouse on this and import this. Okay, import this array list from java.util package. Now the object of the child class can be assigned to the variable of the variable that is declared with the list interface. And here some warning message is coming, yellow color warning message. So I have to provide the generic type depending on the type of the objects that you would like to store into this list. So here, let's say integer. I'll simply say integer, guys. And here, I'll add some elements into this list. List.add, I'll say 9. Then list.add, I'll say 5. List.add 1. Then list.add, then 7. Then list.add 6. List.add. I'll add good number of elements, guys. Let's see what is happening. 2. List.add. Then 4. List.add. 3. Then list.add. 8. Then list.add. Okay, some 22 list dot add, some 11 list dot add, then 99 like that. I am adding a lot of elements here, and list dot add 77 or 73 otherwise. Okay, 73. That's enough. Good number of elements we have added to the list here. Okay, by creating an object for the array list and assigning to the variable of which is declared with the list interface, I'm able to add all these elements. Now, this first element will be stored at the index 0, guys. Okay, the second element will be stored at the index 1. The third element will be stored at the index 2. Third element, fourth element at the index 3. Fifth element at the index 4. Sixth element at the index 5. Seventh element at the index 6. Then index 7, eighth element, index 8, ninth element, index 9, 10th element, index 10, 11th element, index 11, 12th element, and index 12, 13th element. Okay, like this, starting from 0 to 12, this many number of elements are there, right? They are being stored at a particular index. So in list, we have the indexing concept. In list, we have the indexing concept. And if you want to access these particular elements, okay, any particular element you want to access, right? You can access with the help of their index case. For example, system.out.println list.get of. You have to give the index case. For example, I would like to access 4. What is the index I have to give? 6. If I say list.get of 6, using the index, I can access the elements in this list. So run this code. 4 will be printed in the output, guys. 4 will be printed in the output. Just see that 4 will be printed in the output because at the index 6 in this list, we have 4. Okay. At the index 6, we have 4. So that's the advantage of the indexing, guys. Okay. Elements can be accessed using their index because of the indexing concept. Okay. But instead, we don't have such kind of indexing concept, guys. Instead, we don't have such kind of indexing concept. What if I create a set here? I cannot create directly an object for the set interface because you already know that. But in interface in Java, we cannot create an object. Control Shift O, and set will be imported from java.util package. And this constructor, you can see that cannot instantiate the type set is coming. That means you cannot create an object for the interface. So we have to create an object for the one of the popular child class of this parent interface known as set interface, that is HashSet. We have to create an object for the HashSet and import this HashSet from java.util package. This is okay. Creating an object for the child class and assign to the variable of the parent interface. But warning is coming. I'll just give the same thing integer. Here also integer only I'll give. The type of the objects I would like to store into the set is the integer. And here, set dot. Again, the same add method is there. I'll just copy all these values, guys. All these values I'll copy. The same way, just in place of the list, I'll add set, 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 set. Just change the list to set, guys, so that they will be added to the HashSet or set. So set. Here, no indexing concept. Here, the first element will not be stored at the index 0. Second element will be stored at the index. It's not like that, okay? There is no indexing concept in the form of, in the set or HashSet, we don't have any indexing concept. Okay, that's another difference. Here, no indexing concept, guys. That's the main thing. If you want to access the elements of this set with the help of an index, it won't be possible, guys. You say set dot, we don't have any method to access a particular element here, okay? So we don't have a particular method or something like get of index kind of method to access the elements available at a particular index because there is no indexing concept, okay? So no indexing concept. So elements cannot be accessed using the index. There's no methods like get method, etc. to access the elements using the index. That is possible in the list. Now, the next one is, okay, the next one is here, it allows duplicates case, okay? Because of the indexing concept here, you can add the duplicates. Already, this particular list has element 9, okay? I'll add the 9 again, add of 9, one more 9 I'll add. It doesn't matter, guys, because this particular 9 is at the index 13, whereas this particular 9 is at the index 0. Since they are at a different index, duplicates are allowed. So what I will do here is, I'll simply write down system.out.println. I'll just print out the list, guys. I'll just print out the list to see what is happening. Right click, run as Java application. Just print out the list and see that duplicates will be accepted, guys. You see, 9, 5, 1, 7, 6, 2. Already 9 is there here. Again, at the end also 9 is there. So duplicate values are allowed because this first 9 is at the index 0 and the last 9 is at the index 13. So doesn't matter. Duplicates are allowed. What about here? What if I have added 9 here, which is a duplicate thing? Here 9 is already there. Again, I'm adding 9. System.out.println. If I print the set here, understand what is going to happen here. 9, no error will come, but duplicate will be ignored. 1, 2, 3, 99, 4, 5, 6, 7, 8, 9. You see only one 9 is there. Any other? Another 9 is there here? No, only one 9 is coming. Only one 9 is coming. Okay, only one 9 is there in this particular printed set. Only one 9 is there. Even though you added multiple 9s, only one 9 is considered. Another 9 is ignored, guys. Another 9 got ignored. Okay, if it is a duplicate, it will be ignored. It will not give any errors, but duplicates are not allowed. But when duplicates are added, right, they will be ignored without giving any compiler error. Instead, okay, they will be ignored, guys. Okay, allows duplicates, doesn't allow duplicates. Fine. Then coming to the indexing, you allow understood, and list allows duplicates, whereas set doesn't allow duplicates, and also it will not give any compiler error. Rather the duplicate element will be ignored automatically. Only one element out of the duplicate elements will be considered. Okay. Then the third one here, the difference between the list and set is it is an ordered collection. The order of the insertion is preserved because of the indexing concept, right? The way in which you added the elements. First you added what? 9. That got stored at the index 0. So the insertion order of this 9 will be preserved. So whenever you print the list, right, the 9 only will be printed first because it got stored at the index 0, then 5 will be printed, then 1 will be printed, 7, 6, 2, 4, 3, 8, 22, 11, 99, 73, 9. Like that, they will be, they will be stored in the computer memory in the same order in which you have inserted or added into this list. So that's the reason when you print the list, right, here in the output, you see that the same order in which you have added these elements to the list, right, the same order is preserved. You see 9, which is at the index 0, is preserved, then 5, 1, 7, you can see that 9, 1, 5, 7, 6, 2, 4, 3, 8, 22, 11, 99, 73, 9, 99, 73, 9. Same order. The same order in which you have added the elements to the list, the same order, they will be stored in the memory, computer memory. Okay, the order is preserved. Okay, order is preserved here. Okay, that's why it's called as an ordered collection. Okay, list is called as an ordered collection. What about the set, guys? In set, the order is not preserved because there is no indexing concept. Since indexing concept is not there, there is no way of preserving the order in which the elements got added to the set or has set. So random order or unordered collection, you can say. That's the reason when you print the set, right, in the output, what you got, you didn't have the same order. You see 9, 5, 1, 7, 6, 2, 4, 3, 8, 22, 11, 99, 73, 9. It's not there. You see, they came in a this is not ascending order, guys, because you say somewhere 99 is there, somewhere 73 is there, somewhere 11 is there. It's a random order. Okay, it doesn't maintain any order. It randomly takes particular order according to its algorithm and all. HashSet or set will store these elements in a kind of random order. There is no ascending or descending order also. This is a random order because you see, if ascending is there, right, 99 should come at the end, but 99 is in between, means it will randomly store the elements into the memory. So insertion order will not be preserved. Rather, in random way, the elements will be stored into the computer memory. Already told you that popular implementation of the list is ArrayList. I already have implemented here. I create an object for the ArrayList class, which is a child class of the list interface, and assign to the variable of the list interface to help you understand this difference between list and set. Here, the popular implementation of the set is a HashSet. So that's the reason we create an object for the HashSet and assign to the variable of the set interface to explain all these differences. So the last and final thing, guys, is where is the list useful? When in which situations we use the list in our programming. We use list in programming for all these reasons where you don't you want to allow the duplicates, you want the insertion order to be preserved, you want the indexing concept to be there. Okay, if all these are the reasons, right, you will go with the list. Apart from that, one more usefulness of the list is random access to elements, because you can easily access any particular element in the list by using its index. Okay, if you want a particular element, if you know the index of that element, you can access it. Okay, so random access to the elements using their index is possible. That's where is the situation where if you want to allow the duplicates and want to access the elements using this indexing concept, and you want the order in which the insertion happened to be preserved, then you will go with the list, guys. But when you will go with the set, you will go with the set when you don't want to allow the duplicates. You want the duplicates to be ignored, and you don't want to store the elements in a particular preserved order, rather random order is okay for you in that cases. And mainly guys, when you want to do a fast lookup means what? If you want to find an element in the set, right? If you want to find an element that is stored in the set, right, it will be very faster when compared to finding the element in the list. The operations like add, remove, and contains are faster here in case of the set. Okay, because of the 0-1 time complexity for basic operations like add, remove, and contains, the fast lookup is possible in set, whereas in list is generally used not for fast lookup but for randomly accessing the elements based on their index. We go with the list. Okay, there's an additional usefulness and all those stuff, but set doesn't allow duplicates, no indexing concept, order is not preserved, and fast lookup purpose, we go with the set. But for allowing the duplicates, indexing concept should be there, insertion order should be preserved, and at the same time, random access to the element should be possible by using their index. In such kind of requirement situations, we go with the list. So these are the programs, guys. These are the programs I covered today. You want to take a screenshot, you can take a screenshot here. You can take a screenshot, guys. Okay, I don't think fine. Yeah, now this is good. Now you can take a screenshot, guys. Okay, you can take the screenshot of this code. Hope that you have taken the screenshot of this code so that you can practice in your machine, guys, later. So that's all for this session, guys. That's all for this session. I'll also copy this code here and then practical demonstration as part of the notes I'll provide. The code coming. No. Control Z. Simply write here code. Okay. Practical demonstration, and this is the code. Okay, this is the code of the practical demonstration. So guys, hope guys you got the answer for this question. So what is the difference between a list and a set? Hope you got the answer with practical and theoretical explanation, practical demonstration and theoretical explanation. Hope you got the answer for this question. So that's all for this session. Thank you. Bye bye.